Hello everyone, my name is Mike Bremford and I'm here to talk to you about the use of CSS Colour 4 in print. CSS is already widely used for laying out documents for print and is used for everything from train tickets to books. In virtually all cases, it does this by converting the layout to PDF first. You can do this by selecting Print from your browser menu, and there are a number of dedicated CSS layout engines for print. The majority of these implementations have been written from scratch, so there are probably more CSS layout engines for print than for screen. Colour fidelity isn't so important for a train ticket, but it's critical for a magazine cover, and even our financial services customers seem to think it matters for their reports. The PDF format makes calibrated colour possible, if not always easy. So we're excited to see CSS Colour 4 arrive. The first time I saw these ideas presented was by Chris Lilly at a CSS and print conference back in 2006, so they've been worth the wait. Why listen to me? I'm Technical Director at BFO.com. We've been working with PDF for some 20 years and CSS for most of that. We're currently developing a new CSS to PDF layout engine. We're part of the CSS working group and we've fully implemented CSS Colour 4. So this presentation is largely on how we did it and what problems we hit. On the next slide, we'll start with CSS Colour 3. That defined the sRGB colour space and also HSL, which is nothing more than a way of describing a colour in the same sRGB colour space. By contrast, PDF has no sRGB colour space, so right away we have to make a choice. We can choose the device-dependent RGB colour space, which may or may not be sRGB. Being device-dependent, it's going to vary depending on how the PDF is displayed. If we don't really care about the exact colour, it's probably close enough, and it's the choice made by a lot of PDF software, like when you print from your browser. Or I can embed an sRGB ICC profile in the PDF. There are other ways to describe a calibrated colour space in PDF. The CalRGB and CalGray spaces I've listed on the slide, but they're essentially a poor man's ICC profile and not fully capable of displaying sRGB. So I'll lump these all in together. On the next slide, we have CSS Colour 4, which adds HWB. Exactly with HSL, this is just another way of describing colours in the sRGB colour space. We've got ICC profiles, which obviously correspond to the same in PDF. Several of these are predefined in CSS, for example display P3, but they're all still ICC profiles. We have device CMYK, which is great as we have exactly the same in PDF. This is obviously device dependent. 100% cyan will look different on different printers. And we have lab color. Well, we have that in PDF too. And finally in CSS we have LCH, which, just as HSL is to sRGB, is another way of describing colors in the lab color space. Finally, for completeness, there are two other types of color space in PDF which have no correspondence in CSS: device in and separation color spaces. These map a custom set of components to an existing color space and are how we do spot colors in PDF. They're specialized and useful, but they're not part of CSS4, so not up for discussion today. So on the next slide, you can see that LCH really is just another way of describing a colour in the lab colour space. Lab uses A and B, which are Cartesian coordinates, and LCH uses C and H, the radius and angle around the circle, which are polar coordinates. The L value remains the same, so it's trivial to convert between the two. The same statement applies to HSL and sRGB, although the maths is a little different. So if you have an HTML page using LCH colour and you want it in PDF, you can simply convert the LCH values to lab. On the next slide, you'll see there are problems with this. If you have a gradient with LCH colours at either end, you might expect it to interpolate between those endpoints in LCH. But as you can see on the left, if we convert to lab and interpolate in lab, we get wildly different results, even though the endpoints are identical. By the way, the current published version of CSS specifies that all gradients interpolate in sRGB, but this is under discussion, and I'm assuming this will change at some point. On the right, you can see the same gradients presented against the lab colour space. The straight line through the middle is our linear interpolation in lab. It passes through the centre, so we get a sort of grey colour. The curved line is how we move through the lab space to get the same gradient we'd expect in LCH. A semicircle with the C component, the radius of 70, and the hue moving from 135 to 45 degrees. So, given a gradient is simply a function between two colours, to simulate LCH in lab, we just need to control that function. This isn't possible in CSS, but PDF gives us plenty of options to do this: exponential functions, sampled functions, and even PostScript. The approach we take is to start by assuming the function is linear, measuring the difference at the midpoint, and if the difference in colour is too large, we subdivide the curve and repeat for both halves. This is the standard de Castelao algorithm, commonly used with Bezier curves. The advantage of this approach is it works for any curve, not just LCH, so we can apply it universally. So we can update our table now with the equivalence between CSS and PDF, and you can see that if it's possible in CSS, it's possible in PDF. Of course, there are a good number of specification and implementation issues which cause us problems. PDF has restrictions on the types of ICC profile it can use. An ICC profile is just a mapping between a universal color space, always XYZ or lab, and whatever color space the profile is defining. PDF limits us to grey, RGB, CMYK, and lab only works with an 8-bit lookup table. These restrictions are odd, and the last one in particular is absurd, but they've been in the spec for 20 years, so they're baked into all sorts of printer firmware. In practice, it's not a huge problem. Anything not in the subset is pretty esoteric. One example is Fogra 55, a 7-color process with cyan, magenta, yellow, black, orange, green, and violet. Fogra released a beta ICC profile for this condition just 5 months ago. Another one worth mentioning is an XYZ identity profile, where you specify the components directly as X, Y, and Z values. This one is significant because CSS Color 4 lists XYZ as a predefined ICC profile. Well, we can't use it in PDF for this reason. I'm not a color expert, but I'll state that for any visible XYZ colors, they can be mapped exactly to a color in the lab space, just like for LCH. So that's exactly what we do for XYZ colors, just convert to lab. CSS Color 4 supports named color ICC profiles, which are just a list of color names and values, for example, the Pantone range of colors. These aren't supported by PDF, although named colors certainly are with the device in space I mentioned earlier, and it's trivial to convert a named ICC profile to one of these. But finally, the main problem we hit while implementing this was 2D gradients, i.e. parametric surfaces, or gradients that vary over 2 dimensions. These are implemented in PDF as Kuhn's patch shading. The concept isn't directly a part of CSS, but they're the only way we can render conic gradients, which of course are. They're also used by the mesh gradient paint server proposed by Inkscape for SVG, a proposal we like very much and we've implemented. The problem is that most PDF viewers interpolate the patch in the wrong color space. The spec is clear this is wrong, so I'm going to call it an implementation issue, but none of the PDF viewers we tested got it right. I thought we'd found a way around it a few weeks back, but I was wrong. Instead, the gradients I'd drawn had been automatically broken up into smaller steps, so I couldn't really tell which color space the interpolation was happening in. And that's ultimately the solution to this problem. We must subdivide our patch into smaller parts, so the interpolation occurs between colors that are already fairly similar. For conic gradients, this means drawing the arc in smaller steps. The slide shows an LCH conic gradient drawn with 45-degree segments. For general SVG mesh gradients, this is considerably harder, but it's still possible. Next slide, what difference will CSS Color 4 actually make for print? Well, somewhere between none and a lot, depending on your point of view. Most documents intended for print use RGB or CMYK. Spot colors are common, and where calibrated colors are required, they're typically done with ICC profiles. Lab is used, but it's less common. That's reflected in the CSS print engines, all of which already support CMYK. In fact, by happy coincidence, most even use the same syntax. ICC colors are also fairly widely supported, although the syntax varies. So while CSS Color 4 may not offer much new functionality, the very fact that it is a standard is significant. Being able to preview CMYK content in your browser before printing will make CSS print workflows simpler, and I'm sure we'll see the inevitable Stack Overflow posts describing how to specify ICC color in a web page, which will encourage layout engines to adopt the syntax, probably alongside their existing one. It all brings awareness that CSS can be used for print, and that's a good thing. Finally, there's been a shift away from generic PDF to 2 subsets of PDF. PDF-A for long-term archiving of PDF documents, and PDF-UA for accessible PDF. This is the PDF equivalent of WCAG. Both require all color to be calibrated. Legislation has driven adoption internationally, and we also saw a large surge in interest in PDF UA about 2 years ago, after Domino's Pizza lost a court case in the US for not making their website accessible. Suddenly, everybody started caring about accessibility. So if you're generating a PDF invoice, there's a very good chance you'll want it to use only calibrated color. And if you're designing that invoice in CSS and HTML, specifying the colors using an ICC profile will ensure it meets the accessibility requirements when converted to PDF. So that's my final slide. The slides for this presentation are online in both HTML and PDF format. If your browser supports CMYK, LAB, LCH and the other color spaces I've talked about, then the various diagrams will render in those colors. If not, you'll see bitmaps. The PDF version was created with our own PFO publisher, and that does support everything I've just talked about. Hopefully we'll have a public beta by the time this presentation goes out, so the PDF version of the presentation demonstrates all of the techniques I've just described. That's it. Thanks for listening.